Hello all. In this video tutorial, I am starting tutorial classes for the wireless sensor network lab setup. Now I start with this small tutorial on TinyOS operating system. So this TinyOS operating system is used for the wireless hardware devices called mods, and it is freely available operating system. So let me brief about the operating system, what operating system is. So operating system provides an interface between your hardware component. Here my hardware component is any mod or any sensor node which is used in wireless sensor network. Now operating system provide an interface between an hardware and a program, user defined program. So here whenever we write something on our we write something or some code for our wireless sensor network, and if we want to embed this code on your hardware, then a operating system is needed in order to communicate for your program with the hardware. So here TinyOS provides a medium or an interface between your user program, which contains some application, and the hardware, which contain some configurations for the different type of applications, like hardware for the pressure sensing, temperature sensing, and many more applications may be there. So a TinyOS is a operating system especially made for the mods in the wireless sensor networks. So let's start with the introduction part of the TinyOS operating system. First is, it is an open source project which have BSD license. BSD license means Berkeley Software Distribution. These licenses are generally issues to those softwares or programs which are freely available in the market. These are the online links, official links for the TinyOS. You can go to the Berkeley website, which contains all the updates regarding the TinyOS operating system, as well as some other things like tutorials and the installation procedures and all. Secondly, GitHub also has been developed for TinyOS, in which all types of programs and applications are available. You can directly go to the GitHub repository and download the applications, sample applications provided by the Berkeley. So this TinyOS is mostly used operating system for the sensor networks nowadays, and it is developed by University of California, Berkeley, and it supports NES-C programming language, network embedded C programming language, to program application in the sensor node. So NES-C language follows the object-oriented paradigm, and it is similar with the C and C++ language with some syntactical differences. Now, next is, why do we need a new operating system? Why traditional operating system does not work in case of hardware devices, hardware like sensor mode? So the reason behind that we need a new operating system is totally depend upon the type of hardware we are using, because operating system is only dealt with the hardware. If your hardware configuration changes, it means it have some constraint with the hardware which evolve the need for the operating system. So let's see what are the constraint with this type of hardware available. So we have modes with low power. So battery is a prime constraint in our sensor nodes. So the sensor modes are having lower power. They have limited memory. They have limited memory spaces like 4 KB or 2 KB. They have slow CPU, 8 megahertz or something CPU capacity is available in almost all types of commercially available sensor modes. They have small sizes. Limited hardware parallelism is possible in this type of configurations. They communicate using radio. means wireless communication is there. We do not have IP addresses. They provide low bandwidth. Generally, they use ISM band for the communication, and they are short range. So they are using wireless PAN like 802.154.4 standard for the communication, and thus range for the wireless PAN is very limited, approx 10 meter to 15 meter. So they have the short range. Now, with these constraints, we cannot have the traditional operating system which will work on multi-threading architecture, and multi-threading architecture requires more memory and as well as CPU capability. So, keeping in mind with these constraints, your traditional operating system does not work, which are huge, which follows multi-threaded architectures, requires large memory, they have input-output model, they have kernel and user space separations, they have no energy constraints, and they have ample of available resources. So the traditional operating systems are designed keeping in mind that your computer systems are full of computation power, full of memory, as well as they have some type of all type of resources which have to be managed by traditional operating system. So due to the hardware constraints, we require an operating system which will work on the lesser power, limited memory spaces, and small CPU computation power. So TinyOS is a solution for this problem. So because the TinyOS provides these types of facilities, like it support concurrency in an event-driven architecture mode. So instead of multi-threaded architecture, it support a event-driven architecture. Means whenever a event is occurred, only when then the node will take into action. So this event-driven architecture helps a lot in using less memory space as well as less computation power. Secondly, this type of uh, architecture provides modularity based on the application, which have scheduler plus graph of components. Now, components is a basic unit of a program which is used in TinyOS environment, and scheduler is nothing but the interaction between these components, or the way on which, or the order in which the components have to be called or have to be incurred. Now a component contains commands, some event handlers, some internal storage, and tasks. Tasks are the actual work performed by a sensor node. So that's why we are calling the components as a basic unit of the program, because they have the actual task which is to be performed by a sensor node. So by the component architecture, your TinyOS supports a software modularity. So every application which is developed in TinyOS environment, it must support the component architecture, and every component have some commands, some event handlers, some internal storage, and tasks. Now next is efficiency. So efficiency means every time component is occurred, some task is performed, and whenever it is done, a sensor node goes to sleep mode. So that's why it is efficient, because the power which is consumed is very less in these type of scenarios. TinyOS also supports a static memory allocation, so there is no heap in this TinyOS environment. So the memory architecture of TinyOS can be drawn as we have some stack memory which is reserved for function calling and local variables. We have some free memory space which is occupied by a program, user defined program, and we have a global memory space in which global variables and other variables are stored. So your static memory location is there, in which no heap is there, no malloc function is there, there is no function pointers, and there is no dynamic or runtime allocation. So all things are on its stack, functions are on a stack. Now, for the global variables, they are assigned as per frame basis. They conserve memory, so we have because they conserve memory, we define a separate memory space for the global variables, and they can use the pointers. So global variables can use the pointers. They have different memory space in our sensor mode. So when we declare a global variable, the global variable may be a reference or a pointer to some component or interface. So we will see in the detail when we program in nesci language. Third is local variable. So local variable are the variables which is stored in a stack or free memory spaces if these local variables are in user defined programs. So these local variables are generally saved on stack and declared. They can be declared within a method. So within a method they are treated as a local. Okay, so this is a memory model supported by a TinyOS architecture. So the point here is we have to follow a static memory location for all types of programs. So heap is not there, so dynamic memory location cannot be supported. Now there are some concepts for the TinyOS and nesci programming language. Because TinyOS supports only nesci programs, and the basic unit of nesci program is component. So component generally contains processes which is commands. It generally throws events. It has a frame for storing local state of a variable or a local state of a task or local state of a component or sensor mode. It uses tasks for the concurrency. It means that we have different types of tasks defined, and to perform concurrency we have to call these tasks one by one or call these tasks simultaneously. So tasks are the actual work done by the sensor modes. Next is components also provide interfaces. The interfaces are the components like structure which is used to communicate uh, between the components. So various components are there defined, and these components can communicate with each other by the help of interfaces. Now a component generally contains two things. One is your module and other is your configuration. Now module is defined as a code for the component, means what are the actual code or actual task for this component, and the configuration file generally defines the wiring between these components. So this configuration file is generally made by the interfaces as we defined above, and this code for the components is defined by the task or events, and task includes events and commands. So this module have some events and some commands as well as some tasks defined in it. So component, whenever you define any component, it contains a module as well as a configuration file. Now this is a TinyOS sample application. This sample application have a component X, component Z, and a configuration file. This component X have some interface Y. In this interface it will command means this interface have some functions, some variables. So by a command you will call those functions. Suppose x1 is a function defined in interface Y. Here is a command x1 event x2. So in component X you just calling this x1 by the variable y of interface Y. You can also throw event x2 of Y interface by event syntax. So this command and event is included in a component, and these commands and events are defined in interface separately. Similarly, component Z also uses the same interface Y and call the command x1 and handle the event x2. So this component Z is also using these uh, two construct, that is command and event. Now these two components are wired by a configuration file. Wiring means first this z.y means this component will call its interface y, and this in direction with the uh, interface y defined by x. Means in order to call the event x2, it will call by a z component, and because the x2 is defined in the component x in the interface y, that's why we require a link between this x dot y by the help of z. So this is nothing but a pointer type of structure, and you can understand it by suppose there is a z dot y pointer which is pointing to a definition of y where the command and events are defined. So just the address of these definitions are in z.y, and z.y is only the calling mechanism by which we are jumping to the actual definition. In this configuration, so this configuration file is generally wiring between the different components. So some components may have used system defined interfaces or system defined components. So generally what is the application in TinyOS? In left hand side we start with the main component which is defined by a system, and in the left hand side sorry in left right hand side in left hand side we have system defined components, and in right hand side we have user defined components. So from system defined components we will jump to the user defined components, and if then from user defined components we will jump to the system defined component in next line. So because every node must be initialized before any function to be performed. So if a node is in sleep mode, we require some system defined components in order to invoke that node. So these system defined components must be at the left hand side of the wiring, and then when it will call the user defined components, the user defined components may perform some functions, and that those functions may require some hardware interfaces, and those hardware interfaces may be system defined components. So in next line you can have user defined components at the left hand side and system defined components at the right hand side. Now these are the some computational concept for the TinyOS environment. As you can see, a component contains some events, commands and tasks. So let me brief you on the terminology. What is event actually? What are the commands and tasks? So events are time critical applications or time critical constructs. So based on the timeline events are happened. Events may be changed according to the state of the sensor node, or you can say that state may be changed according to the events of the sensor nodes. So events are nothing but interrupts in the operating system, and you can aware what is an interrupt. Here interrupt may be introduced by a timer or some analog to digital converter mechanism or some type of sensors like pressure, temperature and all. So these type of sensor can cause a event to be occurred, and these are nothing but some interrupts, and these interrupts are of short duration and they can preempt task, but it is not possible in vice versa manner. So these events may preempt some task. Task is preempt some task means a task is going on, they can stop this ongoing task and override its priority on this task. So these are events. Now next is commands. So commands are nothing but a request to a component to perform some service. So we have some code for the commands which is used to by the component to perform some service for the sensor node. So these are non-blocking components. You cannot preempt these components, and they need some return status, means what is the outcome of the service. So they are also postpone time consuming work by the posting a task. They can split without callback events. They can call the lower level commands. Here lower level commands means hardware based command. So in order to perform some service, they require some hardware based commands or components to be called. Then next is task. Task is a time flexible construct so they have delayed some processing power. They run sequentially by TinyOS scheduler, means whatever the task comes first, they are served first. So it is in first input first output manner, or first come first served manner, FCFS basis. They run till completion with respect to other tasks, till some event does not occur, because event can preempt the tasks. They can be preempted by the events. Okay, so these are the things which we will use in our NSC programming language when we study it. So yeah, I am just briefing these things so that overview is taken. So in next lecture we will learn about the basic programming language, that is nested language. We will try a simple program of power up a LED node and then sleep that LED node, and we will also see the example of blink the LEDs in the sensor mode. So thanks for watching this video, and please be in touch to see the next video lecture on the nested language. Thank you very much.